We are going to solve linear systems by graphing. So hopefully you guys have some graph paper at home. If you don't, you can always find graphs that you can print online, or if you want, you can make your own graph so that you're able to solve these linear systems. So what is a linear system? A linear system is a set of more than one equations, so more than one line. So if we look to the right here, this is a linear system because it's more than one line. So anything that's made up of more than one line is called a linear system. So the solution to the linear system is where the lines meet. So the solution to this linear system would be right here. So this is also called the point of intersection. So point of intersection. I feel like in Zootopia, where they're trying to tell the joke to the sloth and it just keeps dragging on. Intersection. I guess I could have typed it in, but this was much more fun. So it's the point of intersection. So we can abbreviate it to point of intersection, POI. So when we solve linear systems, the point of intersection is the solution. So for example, the two lines on the graph have a solution of 7, -5. So the point of intersection is actually a set of coordinates given as your x and your y. So we found this by counting across 1, 2, 3, 4, 5, 6, 7, and then down 1, 2, 3, 4, 5, and then we come across to where it meets, and it's right here. So the point of intersection is 7, -5. That is the solution to this linear system. So the equation of these two lines form the system at a solution of x is 7 and y is -5. So to solve a system by graphing, we need to make sure that the equation is in the form of y equals mx plus b. So here, if it's in standard form, where it's 4x plus 3y plus 7 equals 0, we need to rearrange it like we did in the last unit into the slope y-intercept form. So make sure that it's in the form of y equals mx plus b. Then it says to identify the m and b for each. So m, if you guys remember, is your slope, which is equal to rise over run. And our b value is our y-intercept. So the b is the y-intercept. And that is where our line touches the y-axis. Third, you're going to determine where the two lines intersect. That is the solution to the system, and you're going to identify the coordinates. This is the point of intersection, x, y. So given as a set of coordinates, x always being first, y always being second, as it is in the alphabet. So we're going to do our best to graph this on here. You guys will have rulers, so hopefully that'll be better than the way I'm about to graph, but we will do our best. So we are going to graph these two lines on the same graph. So the first line I'm going to do blue. So that's this line here. So 5x minus 1. So our slope is 5 and our b value is -1. So we don't even have to rearrange this. So we know that we are going to have a dot here at -1, and our slope is 5. So that means if we think of slope as rise over run, it's really 5 over 1. So for every 5 we rise, we're going to go over 1. So let's do that. So from our y-intercept, we're going to go up 5. So 1, 2, 3, 4, 5, and we're going to go over 1. So that is where our line is. So if we draw the line, sometimes you have to extend the line beyond. So that would be basically where our line is for the first one. So if we're using our second line, we've got a y-intercept of 4. So 1, 2, 3, 4. So this b value is 4. Our slope here, we don't actually see a number. So we assume that it is 1. So from here, we're going to go up 1 and over 1. And then we are going to draw our line. Oh, shoot. Nope. We're going to draw that a red line. This one's got an arrow. Last one didn't. Just draw it like that. And then we're going to just draw it. I don't know why it turned black. We're going to draw it through here, just like this. So we've got our two systems, and we've got where they intersect. So because I'm drawing this on my computer as best I can without a ruler, we are going to identify this right here as our point of intersection. So on the grid, our point of intersection, remember, is given as a set of coordinates. So the point of intersection, what is our x value of this point of intersection? Well, it's 1. So in our brackets, we've got a 1. And then what is our y value? 1, 2, 3, 4, 5. So our point of intersection for this linear system is 1, 5. Okay, so we've graphed the lines, we found out where they cross, and identified our point of intersection as 1, 5. So let's try this one again. So we have to rearrange this. So when we see these two lines here, we see that they're not in the form of y equals mx plus b. So we're going to rearrange it. So in order to rearrange it, we're going to take this and send it over to the other side. Just like on here, we're going to have to send this one to the other side of the equation. So when we do that, remember when stuff crosses the equal sign, we've got to change the integer, -3x plus 7. So we can see now that this is in the form of y equals mx plus b. We've taken this positive 3x, put it to the other side, changed the integer. So this one is done. This one is ready to be graphed. When we take a look at this one here, we are going to send that 3x to the other side, and we are going to be left with 2y equals -3x plus 8. But if you notice here, y is not alone, so we need to divide out the 2 from every term on both sides of this equation. And when we do that, we would be left with y equals -3 over 2 x plus 4. So now both of these are in standard form, or sorry, slope y-intercept form, and we are going to graph these on our grid. So when we see a negative slope, in terms of rise, that means we go down rather than up. So the vertical will be down for here. So if we plot our first point at 7, so y is 7, that's our y-intercept, 3, 7, and we know we're going down 3 because our rise is negative, 1, 2, 3, and we assume our denominator is 1, and we are going to plot our point right there. Make sure I use the right color, and our line is kind of gonna go, see, undo. And I'll just kind of extend it like that. Then we are going to plot our second line. So here we're going to start at 4. Our y-intercept is 4. And our slope again is negative. So this means we're going to go down 3 and over 2. So our rise is negative 3 and our run is 2. Oh boy. Didn't that work out nicely? And then again, we'll draw our line right through here. So again, using your graph and my graph, we're going to see our point of intersection is right on that line. So what is the point of intersection? What is the solution? So you guys would just write the point of intersection is equal to our x coordinate, which is 1, 2. So we move over 2, and our y coordinate is at 1. So the point of intersection is 2, 1. That is the solution to this system of equations. During the winter months, Don uses his pickup truck to clear snow from driveways. Don charges a flat fee of $50 for the season and $5 per plow. Morgan's snow removal charges $150 for the season with no extra charge per plow. Write an equation to represent the total cost of each option. So if we are going to write an equation for Don, so his charges, his total charges are going to be in terms of Y. He charges a flat fee of $50. So this is the important information, $50 and $5 per plow. So if he's $5 per plow, we'll just call the plow a value of X, and he charges $50, this is going to be Don's equation. Morgan charges a fee for snow removal of $150 with no extra amount of money. So if there is no per plow rate, it's just a flat fee, Morgan's equation is going to look like this. So just as a side note, when we have an equation of y equals 150, this would mean that we would go up all the way up on our y value till we get to 150, and that would be a horizontal line at y equals 150. So for all x values, it doesn't matter how many plows is made, $150 for the season. And then we could graph Don's accordingly as well. So the question here is, how would you find the cost? How would you find when the cost is the same for both companies? So if we're looking for the same cost, we're looking for the point of intersection. So in this case, that would mean the costs are the same for both companies. And remember, the point of intersection is the solution. So keep in mind, if it's asking you for the solution of the system, we are looking for the point of intersection. So here's your work. I will post the screenshots and let you guys know which questions you need to submit. And as always, send me your EDSB questions if you have any, or send me your questions through EDSB if you have any.